Hello everyone, welcome to my data science series 10th lecture. In this lecture, we will cover topic dimension reduction. Dimension reduction is a powerful technique in machine learning that simplify high dimensional data while preserving its essential characteristics. Why dimension reduction? First, pros of dimensionality. High dimensional data can be difficult to visualize, store, and process efficiently. Second, computational efficiency. Reducing dimension can significantly improve the speed and the performance of machine learning algorithms. Third, noise reduction. Dimension reduction can help identify and remove irrelevant or redundant feature in the data. Principal component analysis (PCA) is a statistical technique that reduces the number of dimensions in dataset by transforming it into a smaller set of variables called principal component (PCS). First, data centering. Separate the mean from each feature to center the data around the origin. Second, convariance matrix. Calculate the convariance matrix to capture the relationship between features. Engine decomposition. Find the evidence and values of the convariance matrix to determine the principal components. Visualizing high dimensional data with PCA. Second projection, explained variance interpretation. Second projection. Project the high dimensional data on the top two principal component to create a 2D visualization. Second, explained variance. The proportion of variance in the data explained by each principal component can guide the choice of the optimal number of dimensions to retain. Next, interpretation. The principal component can provide insight into the underlying structure and relationship within the data. Linear discriminant analysis (LDA). Linear discriminant analysis, normal discriminant analysis, or discriminant function analysis is a generalized of Fisher linear discriminant, a method used in statistics or other fields to find a linear combination of features that characterize or separate two or more classes of objects or events. First, class separation. LDA finds the linear combination of features that best separate the classes in the data. Second, dimensionality reduction. LDA can be used to reduce the dimensionality of the data while preserving the class distributive information. Supervised approach. Unlike PCA, LDA is supervised technique that require labeled data to identify the most distributive features. T-distributed sophisticated nether embedding T-SEN. Nonlinear projection, manifold learning, visualization optimizes. T-SEN first, nonlinear projection. T-SEN use a nonlinear technique to map high-dimensional data to a low-dimensional space, preserving the local structure of the data. Manifold learning. T-SENS assume that the high-dimensional data lies on a low-dimensional manifold, and it tries to faithfully represent this manifold in the low-dimensional space. Visualizing optimization. T-SENS is particularly well suited for visualizing high-dimension data as it can relevant complex structure and pattern in the data. Comparison dimension reduction technique PCA LDA TSEN. PCA is a linear technique that finds the orthogonal direction of maximum variance in the data. LDA is a supervised technique that finds the linear combination of features that best separate the classes in the data. T-sense. T-sense is a non-linear technique that preserves the local structure of the data in a low dimensional space. Application of dimension reduction. data visualization, machine learning, anomaly detection, recommendation. Dimension reduction can help visualize and explore high-dimensional dataset. Machine reduction can improve the performance and interpretability of machine learning models. Anomaly detection. Dimension reduction can used to identify outliers, anomalies in high-dimensional data. Recommendation systems. Dimension reduction can be used to create more efficient, accurate recommendation algorithms. Conclusion and takeaways. Dimension reduction techniques, real world impact. Dimension reduction is a powerful technique for simplifying high dimension data while preserving its essential characteristics. Second, techniques. PCA, LDA, and T-Sense are three popular dimension reduction methods, each with its own strength and application. Real world impact. Dimension reduction has numerous practical applications in data visualization, machine learning, anomalies reduction, and recommendation system. Thank you for watching my video. If you like the video, please like, share, subscribe to my YouTube channel. In the next video, we will cover logistic regression modeling.